In the Module 1 test review, we're going to take a look at examples from every section we covered so far. So the first couple we're going to do are review from section 1, so solving linear equations. So the first thing we want to do in problem 1 to solve 4 times x minus 2 plus 1 is distribute our 4 into the parentheses. And when we do that, we get 4x minus 8 plus 1 equals 7. Next thing we want to do is combine like terms. And we have like terms of negative 8 and positive 1, which when we combine give us 4x minus 7 equals 7. Now we can start getting x by itself. So my first step is going to be to add 7 to both sides, which then gives us 4x equals 14. And then our last step is to divide both sides by 4. Now 14 divided by 4 is not a whole number, and we've talked about in the past how we don't want to write the decimal answer, so we want to simplify our fraction. So 14 over 4, both of those are divisible by 2, and when we simplify we get x equals 7/2. Problem 2, we have x minus 4 over 7 minus x over 5 equals 18. The first thing I want to do here is get rid of the fractions. So the way we're going to get rid of the fractions is by identifying the LCD. So when identifying the LCD, you look at the denominators, the least common denominator. So the value that will clear out the 7 and the 5. And that's going to be 35, since 7 and 5 are both, since 35 is divisible by both 7 and 5. So we're going to go through and multiply every term by 35. So we're going to have 35 times x minus 4 over 7 minus 35 times x over 5 equals 35 times 18. Now instead of multiplying 35 to my numerators and my fractions on the left side, what I'm actually going to do is divide them by the denominator. So 35 divided by 7 is going to give me 5 times x minus 4 minus, and then 35 divided by 5 is 7 times x equals, then we want to do 35 times 18, which is going to give us 630. So even though we have that very large value, we're now left with a linear equation very similar to the first problem we did. So now we want to distribute the 5 into our parentheses, and we get 5x minus 20. Now when I take the 7 and multiply by x, I'm just left with minus 7x equals 630. I want to go ahead and combine like terms, so 5x minus 7x, which is going to give us negative 2x minus 20 equals 630. Now I want to add 20 to both sides. So we get negative 2x equals 650. And lastly, I'm going to divide both sides by negative 2. Now, 650 is an even number. So when I take negative 650 and divide by 2, we're going to get x equals negative 325. So even though x is a very large number, when I check it into my original equation, so I do negative 325 minus 4, and then I divide by 7. So negative 325 minus 4 is negative 329. Divided by 7 gives me negative 47. And then when I do negative 325 divided by 5, I get negative 65. So I'm left with negative 47 minus negative 65. And when I subtract a negative, it turns into addition. So I'm really doing negative 47 plus 65, and I end up with 18. So even though it was a large number, it is the correct solution to our equation. Now we want to take a look at examples from section 2, so the absolute value equation. So remember, there are always two solutions to an absolute value equation. Your first solution comes from dropping the absolute value. So if I'm solving the absolute value equation, the absolute value of 2x plus 3 equals 7, my first equation is to do 2x plus 3 equals 7. First step is going to be to subtract 3 from both sides. So we get 2x equals 4. Then we're going to divide both sides by 2, and we get x equals 2. That's our first solution. I now have to set up my second case, which I leave the 2x plus 3 alone, but this time I set it equal to negative 7. So it's the exact same steps as the first equation. We're going to subtract 3 from both sides, and we get 2x equals negative 10. Then we're going to divide both sides by 2, and we get x equals negative 5. So my solutions are x equals 2 and x equals negative 5. If I plug in those values into my original absolute value equation and simplify, I'm going to end up with 7 as my solution. Our next example says negative 3 times the absolute value of x plus 2 plus 7 equals 10. Now before I can solve set up my two absolute value equations to solve for x, I first have to isolate the absolute value. So I'm going to rewrite it here. So negative 3 times the absolute value of x plus 2 plus 7 equals 10. So my first step in isolating my absolute value is going to be to subtract 7. So we end up with negative 3 times the absolute value of x plus 2 equals 3. Now, we're not done isolating, and remember, we can't distribute numbers into an absolute value, so my next step is to divide both sides by negative 3. And when I do that, I end up with the absolute value of x plus 2 equals negative 1. Now that I've isolated my absolute value, I see that it's equal to a negative number. And remember, when we have an isolated absolute value, if it's equal to a negative number, it means there's no solution, which means there are no values for x that when I plug it in, I'm going to be able to simplify and end up with positive 10 as my solution. So number 5, we have 1/4 times the absolute value of 3x plus 2 minus 1 equals 10. So very similar to the problem we just did, we need to isolate the absolute value. So I'm going to rewrite, so we have 1/4 times the absolute value of 3x plus 2 minus 1 equals 10. So my first step in isolating is going to be to add 1 to both sides. So we have 1/4 times the absolute value of 3x plus 2 equals 11. Now here's where it gets kind of tricky. I want to get rid of that 1/4. And I could divide both sides by 1/4, but dividing by fractions, I'm not a fan of. So what I can do instead is multiply both sides by 4. So 1/4 times the absolute value of 3x plus 2 is the same thing as the absolute value of 3x plus 2 divided by 4. And if we're dividing by 4, the way we would isolate it is to multiply both sides by 4. And when I multiply this left side by 4, what it actually ends up doing is 4 times 1/4 becomes 1, so I no longer have anything in front of my absolute value on the left. and we're left with the absolute value of 3x plus 2 equals 44. And now that we've isolated our absolute value, it's still not equal to a negative number, and this is the absolute value we're going to use to solve for x. So my first equation is going to be 3x plus 2 equals 44. So the first thing I want to do in solving for x is subtract 2 from both sides. So we get 3x equals 42. Then we're going to divide both sides by 3. And 42 divided by 3 is a whole number. And it's going to give us 14. So if I plugged 14 back into my original absolute value before we isolated it, and evaluate it, and then multiply it by 1/4 and subtract 1, we're going to end up with 10. Now for the second equation I want to solve, we're going to do 3x plus 2 equals negative 44. And our steps are going to be the same. First, I'm going to subtract 2 from both sides. And we get 3x equals negative 46. And then we're going to divide both sides by 3 again. Now, unfortunately, this time, negative 46 divided by 3 gives us negative 15.3 repeating. And I remember I told you guys I don't like decimal answers, especially if it's a repeating decimal. So we're going to leave our answer as x equals negative 46 over 3. So 14 and negative 46 over 3 are the two values we can plug into our original absolute value equation and evaluate it and get 10 as our final answer. Next, we're going to take a look at an example from section 3, writing the interval notation from a number line. So you have two options. You can either go straight from the number line to the interval, or you can take the number line, write the inequality, and use the inequality to write the interval. I'm going to show the example of writing the inequality first. You're more than welcome to go straight to the interval if you're comfortable with that. So the first thing I want to look at when writing the inequality is which direction did I shade from my number with the circle. So if we look, the number we're starting at is 2, and we shaded everything to the right of 2, which is everything greater than 2. So I know I have to have a greater than inequality. Next, I want to check to see if it's an equal to. And it's kind of difficult to tell here, but it is an open circle at 2. So no equal to, just strictly x greater than 2. So when I'm writing the interval for everything greater than 2, I put a parenthesis with the 2 because it's strictly greater than, and then comma infinity. So that is my interval notation for everything greater than 2. The next two examples we're going to take a look at are the compound inequalities, and we are going to take our solution and express it in interval notation. The first example we have is x minus 1 is less than 7, or negative 2x plus 1 is less than or equal to negative 7. So this is an or compound inequality. We're going to solve each inequality on its own. So to solve x minus 1 is less than 7, we're going to add 1 to both sides, and we get x is less than 6. And we're done. For the negative 2x plus 1 is less than or equal to negative 7, my first step is going to be to subtract 1 from both sides. So we get negative 2x is less than or equal to negative 8. Then we're going to divide both sides by negative 2. Now, anytime you divide an inequality by a negative number, you have to flip the inequality. So because I divided by negative 2, my less than or equal to is going to become a greater than or equal to, and then negative 8 divided by negative 2 is positive 4. So just to refresh your memory, anytime you multiply or divide by a negative, you have to flip the inequality. So now that I have my solutions for my or compound inequality, I need to write my intervals. And we always start with the interval for less than. So if everything less than 6 is going to be written as parenthesis negative infinity comma 6 with a parenthesis because we're strictly less than. Then we do our capital U for or. Everything greater than or equal to 4 is going to get a bracket with the 4 because of the equal to, comma, infinity with the parenthesis. Next, we're going to take a look at an and compound inequality. So we have -4 is less than or equal to 3x plus 2 is less than 11. So anything we do to isolate x in the center, we have to do on either side of the inequality. So my first step is going to be to subtract 2, and I have to subtract 2 from every number. So we get -6 is less than or equal to 3x is less than 9. Next, we want to divide by 3 in the middle, so I have to divide by 3 on both sides. -6 divided by 3 gives me -2, less than or equal to x, less than 3. When we write the interval notation for an and, the smaller number goes on the left side of our interval. The bigger number goes on the right side. So I'm going to have -2, comma 3. Now I have to figure out brackets and parentheses. So my left side says x greater than or equal to -2, so I get a bracket with -2. The right side says x less than 3, which means it gets a parenthesis. So the very last 3 problems are examples from section 5, absolute value inequalities. So combining sections 2, 3, and 4 into one problem. So to solve the absolute value inequality, the absolute value of x minus 6 less than 3, we have to solve 2 inequalities. The first inequality we solve drops the absolute value. So x minus 6 is less than 3. So to solve that inequality, we add 6 to both sides, and we get x is less than 9. My second inequality, we keep the x minus 6, we flip the inequality, and we flip the sign of our number. So it becomes x minus 6 is greater than -3. So we want to flip inequality and sign for number. I'm still going to add 6 to both sides, and we get x is greater than 3. Now we have to figure out, is this an and or an or compound inequality? We can tell based on the fact that our original inequality was a less than, so it should be an and, but I can also test it by reading it. So x, can I pick a number that is less than 9 and greater than 3? The answer is yes. 4, 5, 6, 7, 8. Those are all less than 9 and greater than 3. So I write one interval. The left side is the smaller number, which is 3, comma, and then the right side is the bigger number, which is 9. And because our original inequality was strictly less than, parentheses get put with both of our values. So if you remember from when we did our section 5 practice, I mentioned that sometimes you're going to get values for an absolute value inequality that are the same sign. And this is one of those cases, which is why it's really important to think in terms of interval for an and as smaller number on the left, bigger number on the right, instead of positive negative, because we didn't have a negative value here as part of our solution. All right, next example. 3 times the absolute value of 2x plus 1 is greater than or equal to 6. Before I can set up my 2 inequalities to solve, first I have to isolate the absolute value, just like we would with an equation. So that means dividing both sides by 3. So we end up with the absolute value of 2x plus 1 is greater than or equal to 2. Now I can set up my 2 inequalities. So my first one is going to be 2x plus 1 is greater than or equal to 2. My first step is going to be to subtract 1 from both sides. So we get 2x is greater than or equal to 1. Then we're going to divide both sides by 2, and we get x is greater than or equal to 1/2. 1 divided by 2 is not a whole number. It is a nice decimal. It is 0.5, but remember, I still prefer you leave your answers as fractions. Okay. For our second inequality, we keep the 2x plus 1, we flip our inequality to less than or equal to, and we flip the sign of our number to -2. So now I'm going to subtract 1 from both sides, so we get 2x is less than or equal to -3. We're going to divide both sides by 2, and we get that x is less than or equal to -3/2, because again, -3 divided by 2, not a whole number. So we leave it as a fraction. So now I have to figure out if it's an and or an or. My original inequality was greater than or equal to, so I know it's an or, but if I try reading it as an and, so a number that is greater than or equal to 1/2 and less than or equal to -3/2, doesn't work. So I know this has to be an or, and I want to start with my less than or equal to inequality to solve. So everything less than or equal to -3 is going to be parenthesis -infinity, comma, -3/2, and then because of my equal to, we put a bracket. Then our U for or, and then bracket 1/2 because of the interval, the greater than or equal to, comma, infinity with the parenthesis. Remember, even though we had to put parentheses in here for the infinity and the negative infinity, both of our values had to have the same type of bracket because of our original inequality containing the equal to. Okay. Very last example, we have -6 times the absolute value of 3x plus 1 minus 1 is less than 11. So again, we still have to isolate our absolute value before we can solve. So we're going to add 1 to both sides. So we end up with -6 times the absolute value of 3x plus 1 is less than 12. Then we're going to divide by -6. So we have the absolute value of 3x plus 1. And then because we divided by a negative, we have to flip our inequality to a greater than. And 12 divided by -6 is -2. Now, typically speaking, when we were solving absolute value equations, if we had a negative on the right side, we would say no solution. But that's not always the case for an absolute value inequality. It's based on the direction your inequality is facing. So because our inequality is a greater than, any value I plug in for x is going to be positive and always going to be greater than -2. So this is an example of having a solution of all real numbers. So when our solution is all real numbers, the way we write our interval is everything from -infinity to infinity. So we're going to want to include parentheses with both of those values because we always put parentheses with infinity and negative infinity. Now, if our inequality had stayed a less than, and we would have had the absolute value of 3x plus 1 is less than -2, this would have been an example of a no solution because every value I plugged in for x, when I evaluated it, still would have given me a positive number, and no positive number is going to be less than a negative number. Please reach out if you still have any questions over anything before you take your Module 1 test.